Hi, I'm Sofia Plasencia, and today I'm going to be demonstrating a rising water experiment that models Charles' law and ideal gas law and puts them into action. So for this experiment, you're going to need a glass, a small candle, food coloring, even though it's optional, but it's going to help you see the rise in the water, a shallow dish or even a bowl, but you fill it so the water is not covering the candle, but with enough water so it can rise, and a match or a lighter. Okay, so the first thing you're going to do, which I already did, is fill your bowl with water. And then I'm already going to go ahead and put in a little bit of food coloring, just so you're able to see the difference in the color that rises. I'm just going to mix that in. Next thing you're going to do is you're going to put in your candle, and then you'll light it. Once you light your candle, make sure you do so safely. Then you're going to go ahead, and then you're going to put the jar over the candle, and then you're going to wait. As you can clearly see in the previous clip, that the water in the jar is much higher than the water that's left in the bowl, and it's because it went in. So there are two main components of this experiment that can cause the water to rise, which is a physical component and a chemical component. These two components work together in order to make this experiment happen. The first component I'm going to discuss is the chemical component. So the chemical burning creates a chemical reaction. The flame burns both the paraffin and the oxygen under the glass. Paraffin is also known as candle wax. This reaction uses up oxygen and creates water and carbon dioxide as a result. Twice as much oxygen is burned than carbon dioxide produced, so the volume of the air in the glass decreases. The physical component of this experiment is why the water level in the glass doesn't rise as soon as the candle is covered. The candle warms the air, and this increases the air volume inside the glass. When the candle burns out, because of all the oxygen that is being used up, the temperature cools quickly. The temperature decrease means that the volume also decreases, which lets the water rise up to fill the space, which is also known as Charles' law, which you might learn in chemistry, AP chemistry, so on and so forth. Charles' law basically tells us that the ratio of volume to temperature must remain the same, so if one goes down, the other one goes down too, because they're directly proportional. The big picture of this experiment is that you need both parts to work together. When the temperature decreases, which is the physical component, and the size of the matter decreases, the chemical component, the pressure of the gas inside the glass decreases as well. This lower pressure inside means that water can rise as well, which is also explained by the ideal gas law. Thank you for watching, and I hope you learned something.